Hi there. If you are a Python person, then you probably have noticed some recent announcement around this tool called UV. UV is a tool that allows you to install Python packages a whole lot quicker, and the difference really does feel a bit like night and day. There's a lot of conversations about it, about how it speeds up Docker builds and that sort of a thing, and that makes a lot of sense. But what I figured I might do instead is talk about the new things that it might allow you to do. Because thanks to UV, there's just a few tasks that I can now actually consider that were a lot harder to consider before, and I kind of want to give a bit of a demo around that, because I think other people might find it insightful. So the super quick introduction to UV is that basically you can install this command line. From there you can call UV, and you could say, hey, let's just start a virtual environment. That's something you can do. That's all super nice and quick. Let's source that virtual environment. Good, Bob's your uncle. And from here, you can use UV to pip install some packages. So let's say I want to install Jupyter Lab, and let's then also say scikit-learn. These aren't the heaviest dependencies, but they're also not the lightest. And just to highlight it, this should run pretty quick. Feels like less than a second. And if you just use base pip, it's definitely more than a second. So great, this is really cool. However, UV also comes with a run command these days, and that run command can also do things on your behalf. So just as a quick demo, I have a little script here called demo. It's from their docs. And you can see that I'm importing some things like rich and requests, and these are things that are currently not in my virtual environment. So you could wonder, well, could I even run this? And thanks to UV's new command, the new run command, you can actually give the dependencies in line. So I could say, hey, I want to run a Python script with requests with an extra S at the end, and rich. And then I can point to the Python file in question. It was pretty fast, but basically what just happened is UV actually went ahead and installed these dependencies in a cached mini virtual environment, I guess you could say, just so you can run this script. And again, this barely took a second. But you are able to run some one-off Python code quite easily this way. And that on its own is kind of nice. Like, you can make a decision now that some scripts kind of live outside of your virtual environment, so that your main virtual environment can just be nice and light, but you will have some scripts on the side that can still run some tasks for you. However, UV can actually take this a step further. Thanks to a new PEP, what you're actually able to do is you're able to add these comments on top using a specific syntax. You have to say it's part of a script, and what you put in here has to be like TOML, and you need this requires Python key and this dependencies key in order for UV to do something useful with it. But in short, the main thing that you're able to do is you're able to just declare all the requirements for the script to run directly. And if you do this the right way, then you will not need to use this with requests and with rich at the bottom over here. And that is super neat, because that means that UV run can now point to that rich demo.py file, and all the dependencies are kind of self-contained, and it should just be able to run this as well. Boom. And we can also see from the output that it's reading the inline script metadata from the file over here. So it's definitely using this information in order to run this command. Now, I want to take a moment to just definitely appreciate what is happening here, because at least to me, just that will change the way that I do some blogging. On my blog, I have this Today I Learned section, where I share just a bunch of small lessons that I've learned today. And these are just short articles, they're there so I don't forget. But what I started realizing is that if we can have these self-contained scripts that we can go ahead and share, then maybe instead of just saying Today I Learned, you can also say, hey, today I scripted. And when you share a script that's self-contained, oh boy, that could be super useful to a lot of people. So I've taken that lesson to heart, and on my blog now I have this just list of scripts that people can just go ahead and copy and run locally that are self-contained. Again, thanks to everything I just showed you. So here's a script that I found useful back when I was doing a lot of Prodigy work. It is a trick that allows you to make a more lightweight, spacey model on disk. But yeah, you can just declare your dependencies, and Bob is your uncle. I should mention, by the way, that this script metadata, I believe it will also work with non-UV tooling. It's just that UV really takes care of this very quickly. So again, this is all super cool, but there's an extra trick you can run on top. I am back in Visual Studio Code now, and I have this new script in front of me. Note, by the way, that I've thrown away the virtual environment that was in before. All I got is this new script. When I looked at how fast UV was, I was actually kind of wondering if I could pull off a fun party trick. After all, if Python scripts can run really fast just by knowing the dependencies up front, and we don't have to worry about building a big old virtual environment and that taking a lot of time, I was actually kind of wondering, like, could we maybe do that on the fly, dynamically, from Python maybe? Maybe more specifically, can I actually write functions like this and have them be run in their own little virtual environment where I'm really able to control the version number as well as the dependency versions? And the thinking that I had originally is that this could be really nice when, let's say, there's this one part of the Python program that really needs NumPy version 1, and this other part really needs version number 2, and this is kind of a way to keep small things separate. Turns out you can actually do this. And the way it works is I'm able to take a function like this, and inside of Python there is an inspect module. The inspect module can just accept any kind of function, and then basically you just get the body of the function. So this as a string, that is just given to you. From there, what I can do is I can open up a new Python file. I can make some sort of a function, let's call it main, and let's say that some args and kwargs go into that thing. And then I can just basically put the body of the function below there, and then do the if name equals main thing at the end, where I basically call main with some args and kwargs. The interesting thing about Python, by the way, is that it's really dynamic and that you can also serialize some things. So if I want to inject the args and kwargs, what I basically just got to do is take whatever args and kwargs I want to inject, pickle them, put them in here. You do that with a pickle. And then whatever comes out, that is then something you can pickle back. In a lot of ways, this is a giant hack. But the main thing that I want to observe is that this does actually work, and it even feels slightly pragmatic, simply because UV is so quick. And that, I think, is very interesting. I was really proud when I got this to work, but then like a week later, it also started to dawn on me that besides this being a fun party trick, I also kind of have a use case for this. And that use case is something that I have in this script. So just as a demo, what am I going to be looking at here? Well, I have this function over here called bench, and it is going to be running a PCA on some data that I'm just simulating. But the cool thing about scikit-learn is that algorithms actually do get a bit faster now and again. And in particular, between version 1.4 and version 1.5, we actually saw a pretty significant speed up for certain types of matrices that go into the PCA algorithm. And I figured, hey, can I measure that? Because if I want to measure that, and in order to measure that, it would be super duper cool if I can just loop over version numbers in this Python script to just start measuring. And that's actually something that I'm doing below over here. Now, just for good measure, I made a package called uvtrick. That's a fun party trick in UV that has this env class. That environment class is what I'm using below over here. Basically, what you can do is just pass a lot of arguments that describe the dependency versions that you're interested in. You can also set the Python version. Then with this environment definition, you can go ahead and run functions to your heart's content. You are going to have to pass it the function in question, as well as any args and kwargs that you want to pass along with it. And the whole pickling, unpickling, moving it into its temporary file stuff, that will be happening on your behalf for you. So let's loop over some version numbers, and let's just time this thing. I'm going to do uv run. I'm going to have to install this uvtrick thing that I made, and I also will install scikit-learn just for this data simulation thing that I really only want to do once, because this might be expensive if I do it for big data sets. But anyway, uv run, that should be it in terms of the dependencies, and then I should also just be able to point to that Python file. It's running the benchmarks, and numbers are coming in. All right, and what do we see? From this benchmark, I can indeed confirm that version 1.4, that is indeed a whole bunch slower than version 1.5. So cool, that's kind of neat. But taking a step back, I do want to observe this one thing about UV though. The fact that I can even consider doing stuff like this in a way that's almost pragmatic, that is the cool thing about UV. It's not so much that it's just faster, it's the fact that because it's faster, we can rethink some things now. And I can definitely imagine that I will do a bunch of these scikit-learn benchmarks. I work at a company called Probable. My colleagues do a whole lot of scikit-learn stuff, and it will be kind of cool to archive these speedups and seeing if we can quantify them in hindsight. I do, and also, by the way, if you're interested in researching regressions, stuff like this can also be super duper useful. The main goal of this video really isn't to convince you to use uvtrick. It was made as a party trick, and I don't really know if I want to do some serious stuff with it. However, I do hope that you will also consider what UV might be able to do for you. If you are able to just run these Python things a whole lot quicker, maybe it can be pragmatic to use UV inside of your cron jobs. Maybe that will just speed that up a whole lot as well. I'm also investigating tools and techniques to maybe get this working inside of a Jupyter notebook. If you go onto my GitHub, you will find uvnb, which is a experimental project that I'm building that will basically allow you to do the same UV trick for scripts, but inside of Jupyter notebooks. This can also be kind of cool because you can just declare the requirements that you need inside of the Jupyter notebook. You can call uvnb start, and it will just start a notebook for you with all the dependencies in it. Sounds pretty cool. But again, hopefully you can also consider what might be fun to build. It really does feel like a lot of the tools that we're supposed to be using haven't been built yet. I personally would like to thank the folks over at Astral. They're a little company that built these performance tools, and I think they're doing a cool thing. If they are listening, I am curious to hear more about maybe the long-term plan in terms of financing, because I'm very keen on investing in UV, but it would be cool if there's some sort of signal that UV is going to be around for the long haul, because companies need to make money. But besides that, I'm having a lot of fun with UV. I'm also working on a course for CalmCode as we speak, so yeah, becoming a big fan of that.